In this video, we will be learning about resource allocation graph. So here we have to keep 5 things in mind: definition, what it contains, representation, diagram of vertices and edges, and example. So coming to the definition, the resource allocation graph is a pictorial representation of the state of a system. So as we know, in a system there are many states. So this resource allocation graph will represent each state of the system and it will give us a clear view. So that is a basic definition. Now what it contains. So resource allocation graph contains complete information about all the processes that contain resources, hold resources, and those who wait for some resources. So 3 things we have to keep in mind. Contains all the info about the instances of all the resources are available or being used by the processes. Okay, so all the information it contains which are about the instances of all the resources that are available or which are being used by the processes. So coming to the representation. So here the process is represented by a circle and a resource is represented by a rectangle. So this is the basic representation of the resource allocation graph. So coming to the vertices and edges. So let's draw a diagram about the vertices and edges here. So here this is a diagram of the vertices. So vertices contains 2 parts, process vertex and resource vertex, and process is represented by a circle which is here, and resource vertex has 2 types, single instance and multiple instance. So each instance is represented by a dot in the resource. So here the example of single instance is CPU and the multiple instance is registers. So coming to the edges, so this is the edges. Okay, so we'll have 2 types of edges, assign edge and request edge. Okay, so here the resource is assigned to the process. Okay, and here the process is waiting for the resource. So here in this assign edge, let's take a deeper look here. So tail is attached to the resource. So this is the tail of the arrow and the head is attached to the process. So what does this mean? So this means resource is assigned to the process. So this is nothing but assign edge. Okay, and in the request edge, the process is connected to the resource. That means the process is waiting for the resource. So here the head is connected to the resource and the tail is connected to the process. So this is the diagram of edges, the overall view of edges. So let's take an example here. We'll consider 3 processes P1, P2 and P3, and we'll consider 2 resources R1 and R2. So each resource have 1 instance. Okay, I told you what is an instance. So single instance, that means 1 instance for a resource. So according to the graph, let's take the example. R1 is being used by P1. So how this diagram will be represented? So R1 is being used by P1 means R1 will be pointed towards P1 because it is being used by P1. Okay. So P1 will be connected to the head of the arrow and the tail will be connected to the R1, right? So next P2 is holding R2 and waiting for R1. So let's take the another process here, P2. It is holding R2. That means P2 will be pointed towards the P2 will be connected to the R2. Okay, so R2 will be pointed towards the P2 because P2 is holding R2. So holding means the head will be connected to the process and the tail will be connected to the R2. So tail is R2, that's why it's holding R2 and it is waiting for R1. So waiting in the sense P2 will be connected to R1, that means the head will be connected to the R1 and the tail will be connected to the P2. Okay, so this is the process. So next one, P3 is waiting for R1 and R2. So let's take another process here. Waiting. So what is waiting means? That means the P3 will be directly connected to R1 and R2 because P3 is waiting for R1 and R2. Okay, so the head of the arrow will be connected to the R1 and another head will be connected to the R2 and the tail will be connected to the P3 process here. Okay, so this is one of the example. So these 5 key points, if you just remember: definition, what it contains, representation, diagram, and vertices, edges. Okay, example. So this will be your total resource allocation graphs answer. Thank you.